So now we take our vector equation of a line, which is r equals a plus tb. R is the position vector anywhere on that, so that could be the position of an airplane at a certain time, and you just have a vector so you know that's where that airplane is. You've got your direction vector. Airplanes tend to go in a direction, and they tend to fly in that same direction. And then you have t as time. Depending on what time, you can find out where that position vector is. So now when we think of this with speed, time, and velocity, often we make the a, because a is any point, we make it the starting point. Where did this plane start from? Or where is this boat starting from on the ocean or whatever? And then b, our direction vector, we actually make it a velocity vector, which we can say, based on time t, how far does it travel? So for example, just to put an example here, let's say I was dealing with kilometers and my velocity vector was, do we want to go fast or slow? Airplane or rowboat? Fast? Okay. How fast can airplanes go? 800? Okay, we'll make a semi-fast airplane. This is our velocity vector. Let's say our b vector, our velocity vector was 300, 400. What that would show up in the equation, there would be some initial vector. Maybe it's 0, 0. You're starting at just some fixed point that you say is 0, 0. And here is our equation for this plane. What this velocity vector says that when time is 1, in other words, in 1 hour, it's going to go 300 in the x direction and 400 in the y direction. It's going to be traveling at 500 kilometers per hour. Because it goes 300 to the right, 400 up, it's actually traveled 500 kilometers. And because we did that for t is 1 hour, it's actually telling us our speed. So the length of our velocity vector will be our speed. Right? And I have that here as well. Right? The magnitude or length of it will be our speed. All right, so we have an object. This is its definition. It's starting at some point 1, negative 1. It's traveling 3 to the right, then 4 up. This 3, 4 would be its velocity vector. And t is time. So we're dealing with kilometers here because they're telling us that these are our basic vectors. 1 kilometer east and 1 kilometer north. Because if you would go positive 1 in the x direction, does that make sense that you'd go 1 towards the east? And positive 1 in the y direction would be 1 kilometer to the north. And we're dealing with time. Write down the velocity vector. So the velocity vector is 3, 4. Calculate the speed. Right? The speed will be the length of that velocity vector, 3 squared plus 4 squared. Because if you imagine going 3 to the east and 4 to the north, that is not 3. 1, 2, 3. 1, 2, 3, 4. A squared plus B squared equals C squared would mean that you would have traveled 5 And since we're dealing with kilometers and we're dealing with hours, we would write our speed as 5 kilometers per hour. Describe the motion of this in words. It's traveling 5 kilometers per hour. And I just wrote the direction as a vector. Eventually, in travel, they would actually figure out the angle then. What angle would that be? And they could say it's at a bearing of a certain angle. So we want to take this object, which is written as a vector equation of a line, and what we see here is more of our standard equation of a line. So we don't want the t variable in there, we just want our equation. How did we do that? The equation that we have right now, we have our x coordinate and our y coordinate. We could write the parametric equations, right? Here we go. It'll be 1 plus 3t and negative 1 plus 4t. Remember, these were our parametric equations. And then our other form of the equation was the Cartesian one. The Cartesian one gets rid of the t. Right? If I solved for t in our first equation, I'd get x minus 1 divided by 3. If I'd solve for t in the second equation, I would get y plus 1 divided by 4. So once you have the Cartesian equations, now it's just a matter of, can I rearrange this so it looks like ax plus by equals c? Cross multiply. I want my x's and y's on one side and my variable on the other.